Hello students, in today's video we will learn Werner's theory of coordination compound. So Werner is a Swiss chemist and he is the one who found the first coordination compound. So what he did is he took a compound that is cobalt chloride COCl2 and he added ammonia to it. So this gave rise to a new compound which is a COCl3 6NH3. So now what he did is he added AgNO3 to it, that is silver nitrate. So when he added the silver nitrate to this newly formed compound, he found that there is a 3 moles of AgCl will be precipitated. So it is a white precipitate which is formed when the newly formed compound COCl3 6NH3 when reacts with AgNO3 it forms 3 moles of AgCl which is a white precipitate. So what he thought is this compound in this compound he thought that this Cl3 in this compound is indirectly bonded which is weak. That is, he says that the Cl3 is weakly bonded to the cobalt, and he also says that the NH3, the 6NH3 is directly bonded, which is strongly bonded to the cobalt. So he said that Cl3 is weakly bonded to the cobalt and 6NH3 is strongly bonded to the cobalt. So now he rearranged this component, that is COCl3.6NH3, this compound, to he rearranged this as CONH3 6 times, right? So 6 NH3 6 bracket Cl3. What he did is he put the directly bonded NH3 into the square bracket and the indirectly bonded Cl3 minus outside the square bracket. So this is how he rearranged it. So this is the first coordination compound formed by the Werner. So what he concluded at the last is that he concluded that every metal atom, so that is here the metal atom is cobalt. So every metal atom has two types of valencies. That is the cobalt will have the two types of valencies. Now let's see what are the two types of valencies. Okay, now let's see the two types of valency. Here we have primary valency and secondary valency. So these primary valencies are satisfied by negative ion. For example, we can take as Cl minus. And the secondary valency will be satisfied by the positive or neutral ion. For example, we can take a neutral ion which is ammonia, so NH3. And the next important thing about the primary valency is it represents the oxidation state of the central metal atom, while the secondary valency represents the coordination number. So this is the major difference between them. Primary valency will be equal to the oxidation state, while the secondary valency represent the coordination number. Okay, now let's see the next point, that the primary valency will be always denoted by the dotted lines and the secondary valency will be denoted by a line. Okay, now let's move on to the next point. So these primary valencies are ionizable in aqueous solution. That is, when you put this compound in water, the primary valency will be converted to ions, while the secondary valencies are not ionizable. That is, they will not be ionized. They will not be get converted to ions. So this is the another major difference. So the primary valencies are negative ion, which represent oxidation state denoted by a dotted line and is ionizable, while the secondary valency is positive, represent coordination number denoted by a line, and it is not ionizable. And there are some other differences in which the primary valency is non-directional while the secondary valencies are directional. So for simpler understanding, the primary valency will be equal to the number of ionic bonds, while the secondary valency will be equal to the number of ligand. So it will be simple to understand. That is, the primary valency is equal to the number of ionic bond, while the secondary valency is equal to the number of ligand. So in this coordination compound, the primary valency will be the Cl3 and the secondary valency will be the NH3. So that's it for Werner's theory. So like, share and comment if you'd like this video.